Good morning, everyone. I am Sunil Kumar Vishwakarma, working as an assistant professor in the Department of Computer Science, School of Engineering, Babu Banarsi Das, University, Lucknow. Today, in this lecture, I am going to explain the topic SDLC, Software Development Life Cycle, and why it is used, what is the purpose of SDLC. Now, Software Development Life Cycle SDLC is a framework that defines the steps involved in the development of software at each phase. So, software development life cycle is a framework which defines the steps, and that steps are required for the development of any software. And there are so many phases in the SDLC. It covers the detailed plan for building, deploying and maintaining the software. So SDLC defines the complete cycle of development. That is, all the tasks involved in planning, creating, testing and deploying a software product. Here in this slide, there is a SDLC phases diagram. In this, the first phase is requirement gathering and analysis, and after that design phase, from design to implementation and coding, and after implementation and coding there is testing phase, and after that deployment and the maintenance phase. So all these phases are known as SDLC phases. Okay, SDLC phases, these are the various phases: requirement gathering and analysis, design, implementation or coding, testing and deployment and the maintenance. Okay, now requirement gathering and analysis phase. What we do in this phase, or what a software developer does in this phase. During this phase, all the relevant information is collected from the user, from the customer, to develop a product as per their expectation. Means, if anybody wants to develop a software for the college management, college management software, so first of all, what information will be relevant? That the student information, faculty information, payment information. There are so many things which has to be taken into the consideration. So during this phase, all the relevant information is collected from the customer to develop a product as per their expectation. What you want from the software. Any ambiguities must be resolved in this phase only. Ambiguity means there should not be any dual meaning statement. Dual meaning statements, for example, if we take the example, add 2 to x or y, add 2 to x or y, means this is not confirmed. After reading this statement, that 2 to be added to the x or 2 to be added to the y. So this type of statement should not be there in this requirement gathering and analysis phase. The next point of this requirement gathering and analysis phase is business analyst and project manager set up a meeting with the customer to gather all the information, like what the customer wants to build, who will be the end user, what is the purpose of the product. All these questions must be answered in this phase. Before building a product, a core understanding or knowledge of the product is very important. So before building a product, all these information must be collected, all the ambiguities must be recovered. There should not be any ambiguity. Every question must be answered. Okay, and it should be very clear that which product we want to develop, what is the purpose of that product, who will use that product. That is very important. For example, a customer wants to have an application which involves money transactions. In this case, the requirements has to be clear, like what kind of transactions will be done, how it will be done, in which currency it will be done, etc., etc. There are so many points in this money transaction. Once the requirement gathering is done, an analysis is done to check the feasibility of the development of a product. In case of any ambiguity, a call is set up for further discussion, because that ambiguity must be resolved in the presence of the customer and the developer. Okay, once the requirement is clearly understood, the SRS, software requirement specification document, is created. So this document should be thoroughly understood by the developers and also should be reviewed by the customer for future reference. So at this point we can say that software requirement specification is very important document for the purpose of the development of the software product. Now the second phase of SDLC, design phase. In this phase, the requirement gathered in the SRS document is used as input, and software architecture that is used for implementing system development is derived. Okay, now the third phase is implementation or coding. Implementation or coding starts once the developer gets the design document. Once the developer finds the design document or SRS document, it starts the develop code, that design. The software design is translated into the source code. All the components of the software are implemented in this phase. Whatever the modules are there, all those are tested in the following using any specific programming language. Okay, now the next step is a testing phase. Testing starts once the coding is complete and the modules are released for testing. In this phase, the developed software is tested thoroughly and any defects found are assigned to the developers to get them fixed. The testing is very important, because without testing we cannot confirm that the software system, whatever we have developed, the software product, that will perform as per the requirement. So testing is required. So for testing, there are so many test cases are generated, and on every test case there is some output, and we compare that output with the expected output. If both are same, then we can say that this system is correct. Retesting, regression testing is done until the point at which the software is as per the customer's expectation. Okay, so tester refers as test cases plays very important role in the testing. There are so many types of testing: unit testing, isolation testing, white box testing, black box testing, regression testing, system testing. Okay, now the next phase is deployment phase. Once the product is tested, it is deployed in the production environment, or first user acceptance testing, UAT, is done depending on the customer's expectation. Okay, so in this case of user acceptance testing, a replica of the production environment is created. Replica means copy of the production environment is created, and the customer along with the developers does the testing. If the customer finds the application as expected, then sign off is provided by the customer to go live. This phase is known as the deployment phase. Okay, and this is done after the testing. Next phase is maintenance phase. After the deployment of a product, when the production environment, maintenance of the product, that is, if any issue comes up and needs to be fixed or any enhancement is to be done, is taken care by the developers, and this is the maintenance phase. One question is generally asked in the software engineering course, that which phase of the software development life cycle is the longest phase, is the most costly. So everyone says that maintenance phase, because maintenance is the lifelong process until that product is live. Now the UML is largely process independent, meaning that it is not tied to any particular software development lifecycle. Unified modeling language is a largely process independent. It is not tied to any particular software development lifecycle. However, to get the most benefit from the UML, you should consider a process that is use case driven, architecture centric, iterative, and incremental. So use case driven means that use cases are used as a primary artifact for establishing the desired behavior of the system. So use case, it should be use case driven for verifying and validating the system's architecture, for testing, and for communicating among the stakeholders of the project. Okay, so this is the software development life cycle. Now it should be architecture centric. Architecture centric means that a system's architecture is used as a primary artifact. For which purpose? For conceptualizing, for constructing, for managing and evolving this system under development. Okay, so an iterative process is one that involves managing a stream of executable releases. So it should be iterative process. Iterative process means managing a stream of executable releases. This involves. And incremental process is one that involves the continuous integration of the system's architecture to produce these releases, with each new release embodying incremental improvements over the other. Together, an iterative and incremental process is risk driven, meaning that each new release is focused on attacking and reducing the most significant risks to the success of the project. So it should be architecture centric, it should be iterative process, incremental process, risk driven. Now next, this uses case driven, architecture centric, and iterative incremental process can be broken into phases. A phase is the span of time between two major milestones of the process when a well-defined set of objectives are met. Okay, artifacts are completed and decisions are made whether to move into the next phase. So after this, we can say there are four phases in the SDLC inception regarding UML: inception, elaboration, construction, and transition. So in this diagram, workflows are plotted against these phases, showing their varying degrees of focus over time. Now this is the software development life cycle in connection with the inception, elaboration, construction, and transition. These are the horizontally, it represents the disciplines: business modeling and requirements, analysis and design, implementation, test, deployment, supporting disciplines, configuration and change management, project management, and the environment. So in this graph, it is shown that how the discipline is related with the inception, elaboration, construction, and transition. How the business model affects this inception and elaboration, and there is no role of business modeling in the transition. I think after showing this graph. Okay. Now, what is inception, which we have seen in the this previous slide? Inception is the first phase of the process when the seed idea for the development is brought up to the point of being at least internally sufficiently well founded to warrant entering into the elaboration phase. Now, next is elaboration. Elaboration is the second phase of the process when the product requirements and architecture are defined. In this elaboration phase, the requirements are articulated, prioritized, and baselined. Okay. Now, the system's requirement may range from general vision statements to the precise evaluation criteria, and each specifying particular functional or non-functional behavior, and each providing a basis for testing. Now, the construction. Construction is the third phase of the process when the software is brought from an executable architectural baseline to being ready to be transitioned to the users community. Here also the system's requirement and especially its evaluation criteria are constantly re-examined against the business needs of the project, and resources are allocated as appropriate to actively attack risks to the project. Now, the transition. Transition is the fourth phase of the process. When the software is delivered to the user community, rarely does the software development process end here. For even during this phase, the system is continuously improved, bugs are eradicated, and features that did not make an earlier release are added. Now, next one is one element that distinguishes this process and that cuts across all four phases is an iteration. An iteration is a distinct set of work tasks with a baseline plan and evaluation criteria that results in an executable system that can be run, tested, and evaluated. The executable systems need not be released externally because the iteration yield an executable product, process can be judged, and risks can be re-evaluated after each iteration. This means that the software development lifecycle can be categorized as involving a continuous stream of executable releases of the system's architecture with a mid-course correction after each iteration to mitigate potential risk. It is this emphasis on architecture as an important artifact that drives the UML to focus on modeling the different views of a system's architecture. Okay. Now we can say that software development lifecycle models, there are different types of models. Or software lifecycle model is a descriptive representation of the software development cycle. SDLC models might have a different approach, but the basic phase and activity remain the same for all the models. So waterfall model is very first model that is used in SDLC. It is also known as the linear sequential model. In this model, the outcome of one phase is the input for the next phase. So the development of the next phase starts only when the previous phase is complete. That's why it is known as the waterfall model. Advantages of the waterfall model. Waterfall model is the simple model which can be easily understood and is the one in which all the phases are done step by step. Okay. Deliverables of each phase are well defined, and this leads to no complexity and makes the project easily manageable. But there are some disadvantages of waterfall model also. Waterfall model is time consuming and cannot be used in the short duration. projects, as in this model, a new phase cannot be started until the ongoing phase is completed. This is the one of the advantage. Another advantage is waterfall model cannot be used for the projects which have uncertain requirements, or wherein the requirements keeps on changing, as this model expects the requirements to be clear in this requirement gathering and analysis phase itself, and any change in the latter stages would lead to cost higher, as the changes would be required in all the phases. In this way, there are a V-shaped model. After V-shaped model, there is a prototype model, and prototype model is a model in which the prototype is developed prior to the actual software. Okay, and after that is spiral model. Spiral model includes iterative and prototype approach both. Okay, it has only 4 phases: planning, risk analysis, engineering, and evaluation. Now, iterative incremental model. Okay, so these are the some models of the software development. Thank you.